Electrical service reaches homes from the power utility, through two 120-volt service wires that offer a combined 240 volts of power. The main electrical service reaches your home, either through overhead service wires, that enter a service mast, and pass down through an electrical meter into your home. Or, through underground wires, that also pass through an electrical meter. The first stop for the electrical service, once it enters your home, is the main service panel. In most homes, the main service panel uses circuit breakers that control and protect the individual circuits. Circuit breakers are specially designed safety switches that prevent individual branch circuits from drawing more power than the circuit wires can safely handle. Virtually all homes built since the early 1960s use circuit breakers as the power distribution method. Older homes also have circuit breaker panels if their electrical service was updated after 1960. Where an electrical service was installed before the early 1960s, and has not been updated, it may a fuse panel, which protects individual circuits with screw-in or cartridge fuses. The use of fuse panels and circuit breaker panels for residential wiring follows this historical pattern. 30-amp fuse panel. Installed before 1950, these service panels provide only 120 volts to circuits. Such a service provides insufficient power for modern usage, and generally needs to be updated. 60-amp fuse panel. Installed from 1950 to about 1965, provide 120 and 240 volts of power, but are still insufficient for most homes. An update is usually needed. Circuit breaker panel. Since the early 1960s, homes have generally been wired with circuit breaker panels. This type of panel provides both 120 and 240 volts of power. Early services may provide 60 amps of power, while large houses built today may have 200 amps or more of power. Homes with 60 amp or 100 amp service often require an electrical service update during major remodeling or expansion projects. The main electrical service delivered to your home from the electrical utility company has a total available capacity, measured in amps, or amperes. Most homes have an electrical service of between 100 to 200 amps. Amperage is a measurement of the volume of electricity flowing through wires, and this measurement can vary between 30 amps in very old homes that have not been updated, to as much as 400 amps, in a very large home with extensive electric systems. Everyone needs to know what a breaker box is and what it does. You'll go there to flip a circuit back on, or to shut one off to do some work. A breaker box is your home's electrical service panel. It receives incoming power from the electrical utility, and then safely distributes it to all your various circuits throughout the home. The main service panel is the distribution center that splits the main electrical service into individual branch circuits that run through your home to power the lights, outlets, and individual appliances. The main service panel is usually a gray, metal box, located somewhere along the inside surface of an exterior wall. It is often found in a utility area, such as a garage, basement, or furnace room. When it is located in a finished living space, it is sometimes contained inside a finished cabinet, mounted on the wall. Service panels also can be located outdoors, typically on an exterior house wall. The main service panel includes two hot bus bars that run side by side down the panel. The bus bars are fed by a large breaker called the main breaker. Each bus bar carries 120 volts with respect to the neutral, which is located on one or two neutral bus bars in the panel. A branch home circuit, connected to just one bus bar, will deliver 120 volts of power, while a circuit connected to both bus bars will deliver 240 volts of power. Ground connections are provided by one or two ground bus bars, usually located in close proximity to the neutral. The main circuit breaker is usually located at the top of all the branch circuits, and it cuts off power to the entire house. It is rated for 100, 150, 200 or even could be 400 amps, and it's always 240 volts. Before you start work on any circuit throughout the house, make sure you shut off the power here at the breaker box. The individual branch circuit breakers cut off power to each individual circuit. They are rated for 15 or 20 amps. Amperage is the capacity of the circuit, and determines how much power the circuit can handle before the breaker trips. Higher amp circuits are usually reserved for high wattage appliances like oven ranges or air conditioners. If a circuit breaker trips, it's usually due to a fault, or a circuit overload. An electrical subpanel is a secondary service panel that is fed by the home's main service panel. Subpanels are commonly installed to accommodate the many new circuits and breakers added as part of a home addition or large remodel. A subpanel can also serve as a convenient satellite panel for a detached garage or workshop, that may be located far away from the main panel. Subpanels are typically 60 to 100 amps, and often have branch circuits serving a specific area of the house, such as a kitchen. They have their own main breaker, which is fed by the main panel. If your home has a subpanel, there will be a double pole breaker in the main panel that has the same amp rating as the main breaker in the subpanel. Subpanels don't always have main breakers, they may have lugs only, which allow the feeder wires to be connected. Because the subpanel is fed by the main panel, you do not add the subpanel's amp rating to the household total, use the main panel's amperage only. We have already seen, in a previous video, a subpanel could be the means by which standby power is supplied to a home. This slide shows an actual installation of a smart home panel 2, that has both the generator input, as well as connection to the main grid panel. You can see the circuits that need to be secure entering the panel at the top and are tied to the individual breakers inside this panel. Installers have drilled holes to connect the NMD cables for 1 to 12 load circuits. As I mentioned before, a single Delta Pro Ultra can do an impressive 7,200 watts of output, which is going to take care of most people's needs. And you can add a second or third unit here to get 21,000 watts of output. A single unit can also stack up to 5 batteries for 30 kilowatt hours of capacity. And you can do the math, 3 units can supply 90 kilowatt hours of capacity. The standby generator subpanel does not necessarily have to be placed right next to the main panel. It could be mounted on the outside of the house, or, as in this case, mounted in the garage. The EcoFlow Delta Pro Ultra is one of the most versatile, whole home backup solutions that has just been introduced to the market. This backup power system is designed for both extended outages and daily use. With an unrivaled capacity of 6 kilowatt hours, 7,200 watts output, and 5.6 kilowatts solar input, a single unit can run your entire home. With EcoFlow Smart Home Panel, you get an uninterrupted power backup experience with automatic switchover, energy consumption monitoring, and lower electricity bills. This unit is not driven by gas or diesel generation but uses the battery storage unit that is charged when the utility is available. This means that the unit can be placed indoors or outdoors and is virtually silent when operating. It has a stackable design that can be expanded to increase output in only minutes. Compatible with various energy sources, from solar to gas, to meet your ever-changing power needs. To obtain more information on this subject, and pick up your free digital copy of the Ultimate Guide to Residential Standby Generators, simply fill out the information requested when you go to this website, https://bit.ly/3 uppercase S uppercase P 0 lowercase x uppercase V uppercase Y